Testing 1, 2, 3. Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and we're in here at the lathe. We have a small project here, and I don't think we've ever created a video doing a V-groove for a V-belt pulley. We have a blank here that was made by a customer. In fact, he even supplied us with a hub and the bolts and all of that in case we wanted to use this to set it up. But I chose to set it up in a way that I know that I'm 100% turning true with the register and the face of design on this pulley. Now he's marked off a groove here where he wants to center. And he's machined everything except for the V groove. He's never machined one before, and he brought it to me to do just that. So today we open up the good book on one of our saved pages, and you can see that I have several. So you just this is one of the go-to pages here, and it happens to be V-belt pulleys and sheaves. And now this is 1962 edition, and that was about 7 years after I was born. And back then I was a train engineer. Remember those Campbell soups used to have paper label around, and if you saved those labels, you send them in, and then you could get this train. And of course, it was only 3 to 5 cars long, and it was just basically a carriers with little wheels, and you dropped the Campbell soup cans into them, and instantly you had a train. And my memory's slipping, but some of these things I can remember back. All right, back in the day, because the belt we're going about today is a smaller than a belt, and this dimension is some crazy number like 10 millimeter or something, some metric number. But back in the day in 1962, our small belt used to be a 380 belt. They had A, B, C, D, and E, but then there was a special SAE automotive belt that was 380 in dimension. Okay, so basically between what we actually have in our hand and what we used to practice back in 1962 was about 25 thousandths on the belt width. Now there are other factors of V-belts that are very important. In fact, sometimes they're more important than the actual width of the groove, and that's the angle of the groove. That is the grip the belt works with. And different diameter pulleys change slightly on angle from small to big. There's a size barrier in there, and there's listed size or angle differences in the book. Now we were supplied with the sample pulley, and what the reason why they're making a new one is they need to change the speed of the accessory they're running on the motor. And so that's basically why we're involved with the job. But it being here, and we know that they were running this belt on there, and we know we have a sample of how that sets into the groove. So we'll be able to gauge that, and we'll be able to work our groove until we get the same configuration and the same profile in the height and how that belt rides in on the pulley. Now we did check on diameters here, and back in 62 on the 380 belt they ran a 36 degree angle. Let me double check on that before I 36 degree angle. Now on the standard A size belt, which is the smallest that's in here on the standard dimensions, the old dimensions that still stay today, 38 on something that's over 5 and 7/16 diameter. Anything over 5 inch is 38, and anything up to 5 and 3/8 is 34. Now we wanted to go ahead and just verify what angle was on the stock pulley, or the one that we're replicating that was running on here, and we checked this out, and this matches exactly half of the 38, which we're working one side. So you're going to work one side of your V pulley, and then you're going to work the other side. Alright, so now we know that we're going to go ahead and we're going to be feeding our compound in, and we adjust those angles, and our angle cut is going to be done with the compound. So we're going to be working in 19 degrees from the cross slide on both sides of that V pulley. Alright, we also know that the width on this, right at the very top, and this is just using my guessometers here, about 430, somewhere around in there. And the depth on this is about 1/2 inch, and that's really all we need to know. We don't need to think metric at all. We have decimal, and we have a belt to get the feel and test the fit. Alright, now let's get going with creating our groove in the pulley. Okay, we have already put a slug in here, face this off and turn this diameter. And we turn that diameter until we got our blank. And just make sure that we're all clean on the back side. And then the blank goes right on there. And we put an indicator on this outside here, and we're running like right there. Now this is a large friction plate here, and the phone. Okay, our large friction plate, I'm going to bring it in here. This fits our center, and what we're going to do here too, we're going to be using our parting tool, so we want to make sure that we're in here far enough. That'll be fine there. Alright, and there we go. Tailstock's in position now. And we're locked down. So now I'm going to bring this in here. And I like to leave it a little bit loose. And then tighten it up. Really helps it center itself. Okay. They have marked off a center line of where they want the groove to be. Alright, so we're going to blue this face. Our tuba sharpen. Alright, we're going to use our threading insert, and this is going to be to mark the width of the groove. We're going to line up with that groove, or their mark, and then we're going to move it forward and aft of that line, making sure that our carriage still swings here when we're all the way in here. Alright, we're not hitting anything right there, no crashes, no bangs. Okay, we're good to go. I just hate to turn it on and have it go BAM! Okay. I hate when that happens, right? Okay, basically there's the center of the groove, and we're going to set our travel dial here at 0. We measured their groove here, and we got, we're just going to play it safe, and we're going to call it 420. So we're just going to go over 210 each direction and put a light little tiny scratch in that surface. We'll go forward here first. Okay. Coming in. That's all we need is a scratch. We don't need to make a deep groove. Okay, come over to the other side. Alright. Now that groove is actually slightly to one side of the pulley there, so we're going to have a little bit more meat here than we are back here, just because of the distance there. Alright. Alright, we got our new camera clamp set up here, and to be the right nasty clamp. All right, so now we got a good view looking right down at the bit for you. Now this is how we're going to set exactly center of where we want to put that groove, and we lined up the aft side of our parting tool with the aft line, and we set our travel dial at 0. And now we're going to go ahead and bring it on over to the forward side of the V, and we're just going to call that, actually that should be somewhere around 380, somewhere in that neck of the woods there. Actually, let's see what 300 looks pretty darn close to it. Okay, so we'll come back 150 right there, and we're splitting that line pretty good. I'm happy with that. We're close enough to call that the V center. All right, now we know that we want a 1/2 inch on the depth there, so when we touch the part on the outside, we will set our compound at 0, and then we'll be able to come in the exact depth, and we're going to take this down to a 1/2 inch of depth to match the sample we have. We're all set up now, and I've got some Alumatap over here, and I'm just going to be lightly putting that on here. This is a carbide insert parting tool, and the Alumatap just gives me that crisp cut. Alright, this is about 450 RPM, and I'm going to lightly touch and then set my, there we go, I'm going to set my dial at 0. Alright, and we're just going to put this here lightly. Alright, we're going to do something about the chips flying around there and hitting the camera. 40 to go, 30, 10, alright, we're there. Okay, we set our bit at 0 position. That's where it would have been when it first touched off. Now we're going to fire off the lathe, and we're going to go ahead and pull back our compound. We're going to move it aft. Oh, I don't know. We'll move it aft about 20 thousandths, 25 thousandths, and then we're going to feed in our compound. Out on our compound, there's 25. Now we're going to lightly feed in. And every once in a while we'll give it just a little brush, and then when we get in there we'll pull out our chips, come back out, clear it up again. We're going to go ahead, we're going to go 50 thousandths now. We know we got plenty of room to go. You can see that gloss behind on the cut. You can see the tool bit reflect in it. Bring it back out. We're just cutting on the in direction. Alright, looks like we got about 50 left. We'll go ahead and we'll take a look at it here. Take another 50, well inside our mark there. Now we're getting a little bit of, there we go. Alright, back out. We're going to clear the chips away for you. All right. A little twist of the camera there, huh? Okay. Okay, it looks like 30 thousandths left. Okay, set for another cut here. Let's go. We're going to take 25. Okay, we're going to give this a nice coating here. That came on right on our line there. Now this I'm going to stay even to coarse. Okay, and we're going to feed out real slow. Okay, a little tiny bit of chatter down in there. We got about 5 thousandths more to take on there. We're going to slow down the speed and go in for a final cut on this side. Okay, there's 5 thousandths. Now I could shorten up this parting tool and probably get away without having any of that little chatter in that last little bit there. But this is my standard distance that I run my parting tool most of the time, no matter what I do. But this, if I was doing a lot of these, I would shorten it right up to minimum of what I need. You can always make your setup more rigid by shortening up your tool bit from where it's mounted. Alright, and we took out that chatter that's down in there. And that brings the end of the cut. Okay, bring our tool bit back out. We're going to change our angle and come in for the other side. Okay, we got our angle of our compound, which brings our tool holder, tool block back this way here. And we still have a clearance. We have to pay attention to our clearance down in here. This is where it's safe, and we lack about 2 inches of being in here to go ahead and work this side with our parting tool. So we're going to take out our parting tool and we're going to put another tooling situation in here to get that side of the groove. Okay, we're going to take a fresh tool block, and it's got a nice V in the bottom here, so it holds these 3/4 inch boring bars pretty good. And we're just going to pick a good level position right there, and that's going to give us plenty because we can come back this way here if we need to. Alright, and we'll go ahead and lock that in. Alright, and we're going to come back this way just a little bit. We're going to take out this tool bit here because we need to have somewhat of a tool bit that's going to come in on the other side, be narrow enough so that when it gets to the bottom of the groove, it's not going to hit on the other side. So let's see what we got. Okay, this is one of my old Acme threading tools that has been radiused on the end. It's a little short, but it does reach the bottom. If I can just get enough of it to stick out there and still reach in and clamp this, should be fine. I'm going to see where I'm at on. Okay, pretty good in that. Let me see, 1/2 inch scale. Now I got my 1/2 inch width on the scale here, so we can see that's more than enough to go down in there. We have more than enough to grab the tool bit. I think we're going to be in good shape here. Excellent. All right. All right, let's get set up and make sure that we are tight. And I think I want to angle this slightly like that. That looks good. All right. And excellent. By the time I open that up, we'll have plenty of clearance. Plenty of swing. Always a good thing. There we go. Now we're feeding in instead of forward with our compound and our carriage. All right, there's 25 feeding forward. We're going to keep track of what we got here now. Another 25. Another 25. Alright. The squealing's because I stopped feeding it. I had to stop and pick up a scale that I dropped on the floor. Okay, it looks like about another 40 thousandths, and we'll take another 25 here. This rounded high speed actually almost seems to be cutting a little better than that carbide insert, even though I know that I could have snuck it up a little bit. All right, earbuds. I just wanted to pull that chip out of there. I'm going to stop it for a second. Of course, we got to pull this chips out of the way. All right, now there we go. Just so you can see what we got down in that root there. And we're going to stop and measure that outside width across the face. And that looks pretty close to right at 400. We're going to check out the fit of the belt. Okay, we're laying the belt right in here. And that sits just about same height. In fact, we can double check and see this height right here. All right, we're within 5 thousandths of matching the height of this one right here. Excellent. All right, let's get tool bit out of the way so we don't nick it. And back off our pusher plate here. And our pulley. Excellent. Nice. All right, we got guys hub, and we're going to put it back on here. And we double checked our belt around here in the depth. All right, that's as simple as it gets on putting a V groove in a pulley. And you might be doing multiple pulleys, and you just got to do that right spacing, the right sizes. Everything's in the good book. All right, until next time, get her done.